Namaskar. Welcome in this lecture series on software engineering fundamentals. This is Dr. Bright Keswani, working as professor in the uh, Computer Science and Engineering Department in Suresh Gyan, Vihar, University, Jaipur. In today's lecture, we will discuss about the software testing strategies. As far as the learning objectives and learning outcomes of this lecture is concerned, the learning objectives are to provide you all insights about software testing strategies in detail, and after the completion of this lecture you will be able to understand the importance of testing and why effective testing is required. And secondly, you will understand about uh, the difference between debugging and testing of the software system, and what are the various methods to test and debug the software system. These are the learning objectives and learning outcomes of this lecture. These are the points to be discussed during this lecture. The overview about software engineering strategies. There are so many strategies for software testing. So we will discuss about all these strategies in this lecture. Then some special testing methods are also there. Apart from standard testing strategies, there are some uh, additional methods like defect testing, interface testing, and alpha and beta testing. So we will discuss defect testing, interface testing, and alpha and beta testing in this lecture. Then we will discuss about the object-oriented testing methods, because nowadays we are working with object-oriented tools and technologies. So uh, the object-oriented testing methods are also have some significance. So we will discuss about object-oriented testing methods. Then we will discuss about automated software testing tools. Nowadays there is a automation in software testing. So we should learn about the automation in software testing. So the testing with some tools uh, to automate the testing process, we will learn in this segment. Then debugging and debugging techniques we will discuss in as a last point of this lecture. So let us start with the first point, that is software testing strategies. As you know that software testing is a method of quality assurance, and it provides some strategy and it provides some methods. So software testing strategy provides a roadmap for the software developer, you can say, and quality assurance organization and the customer. Okay, so what is the software testing strategy? It provides a roadmap. A strategy must provide guidelines for the uh, tester, and a set of milestones for the manager. Okay, and progress must be measurable, and problems must surface as soon as possible. There are some basic characteristics also of testing strategies, like testing begins at the module level and works outward towards the integration of the entire system. So testing begins at the module level, means you have to test an individual unit first, then to the whole system. Different testing techniques are appropriate at different times. You cannot imply all the testing techniques at once. Okay, so different time stages in the SDLC, you can implement different techniques. You can apply different techniques at different time interval. Then testing is conducted by the developer, and for large projects by an independent test group. So when you are talking about a small project, a single tester or a developer maybe conducted the testing. But when you are talking about a large or complex project, then a separate independent is group should be there for testing purpose only. Testing and debugging are different activities, but debugging must be accommodated in any testing strategy. Okay, so testing is one thing and debugging is the different thing. Okay, in the later sections we will discuss about the we will differentiate about both terms, testing and debugging. Okay, so uh, this is the general characteristic that there is a difference between testing and debugging. Okay, and you can incorporate debugging within the testing activity. Okay, there are several types of testing methods in order to conduct a proper and thorough set of tests. The types of testing, these are the types of testing. uh, it should be performed in the order in which they are given here. The first is unit test, then integration testing, then functional testing, and then system and acceptance testing. There are various other testing strategies, other testing methods suggested by various scientists like Pressman and Basili, that there are some during the integration testing. The integration testing is having two types: top-down integration and bottom-up integration. And the bottom-up integration is further divided into four categories like top-down strategy, bottom-up strategy, Big Bang strategy, sandwich strategy. And the functional testing is also divided into two types like positive functional testing and negative functional testing. Similarly, system and acceptance testing is divided into uh, six parts, six types like recovery testing, security testing, performance testing, reliability testing, threat testing, and back to back testing. Okay, when we talk about reliable testing is again divided into three segments: robustness testing, stress testing, and load testing. Okay, so this is a general view about the uh, different types of testing. Let us discuss all types of testing one by one. First of all, we will discuss about the unit testing. As the name suggests that the developer or the testing professionals should test individual modules first, which is sometimes called as uh, unit testing. And units means modules. So uh, it is suggested that first of all you should test the module first. So unit testing is essentially a set of path tests performed to examine the many different paths through the modules, and these parts of tests are conducted to prove that all paths in the program are solid and without errors and will not cause abnormal termination of the program or other unstable results. So what is needed in the unit testing? First, unit testing is done prior to the system testing. When you going to test the entire system, first you test each and every module, okay, and their connectivity and their integration and their communication. Okay, next is integration testing. Integration testing focuses on testing multiple modules working together. There are two types of testing, this kind of testing approach. First is top down integration and second is bottom up integration. Okay, so when we are talking about top down integration, the term suggested start at the top of the program hierarchy and travels down its branches, and this can be done in either depth first or breadth first. Okay, the main advantage of this type of integration is that the basic skeleton of the program or the basic skeleton of the software can be seen and tested early. And the main disadvantage is the use of program steps until the actual modules are written. And this basically limits the upflow of information and therefore does not provide for a good test of the top level module. Okay. Let us discuss about the bottom up integration. This type of integration, you can say it has the lowest level modules built and tested first on individual basis and in clusters using test drivers. And this ensures each module is fully tested before it is utilized by its calling module. And this method has a great advantage, you can say, in uncovering errors in critical modules early. So through the adoption of bottom up integration, you can reduce the cost of uh, testing process and the cost of uh, ensuring the quality of the software. Main disadvantage is the fact that most of or many modules must be built before a working program can be presented. Okay, so there are some testing procedures. You can say the bottom up integration you can perform in different ways, like top down strategy is there, bottom up strategy is there, big bang strategy is there, and sandwich strategy is there. Let us discuss about top down strategy first. The top-down integration is basically an approach where modules are developed and tested, starting at the top level of the programming hierarchy and continuing with the lower level. Okay, and it is an incremental approach, you can say, because we proceed one level at a time, and it can be done in either depth or breadth manner. Okay, depth means what? Depth means we proceed from the top level all the way down to the lowest level. And breadth means it means that we start at the top of the hierarchy and then go to the next level. We develop and test all modules at this level before continuing with another level. Okay. Either way, this testing procedure allows us to establish a complete skeleton of the system or product. Okay, so it is a very wonderful technique, and the next technique is bottom up strategy. uh, Bottom up approach, as the name suggests, it is opposite to the top down method, and this process starts with building and testing the low level modules first, working its way up the hierarchy. Okay, and because the modules at the low levels are very specific, we may need to combine several of them uh, into what is something called a cluster or built in order to test them properly. So uh, these are two main strategies: top down strategy and bottom up strategy. Some benefits, or you can say advantages, of bottom up integration are there, like there is no need for program steps, as we start developing and testing with the actual modules. And starting at the bottom of the hierarchy also means that the critical modules are usually built first, and therefore any errors in these modules are discovered early in the process. So it is, you can say, a better strategy than other strategies. Let us discuss the Big Bang strategy. Big Bang strategy is another uh, good strategy, you can say. Big Bang approach is very simple because, in as its name suggests, that its philosophy, where basically all the modules are constructed and tested independently of each other, and when they are finished, they are all put together at the same time. So this is the Big Bang strategy. The main advantage of this approach is that it is very quick, as no drivers or step are needed. So, so this strategy is again a good strategy. Okay. The next, there is a drawback also. What is the drawback of Big Bang? The drawback is that there is a really nothing to demonstrate until all the modules have been built and integrated. So first of all, you have to build a cluster, then you will test it. Okay, build an integration, test the integration, make the integration and test them only. Okay, what is sandwich strategy? Sandwich strategy is the most widely used integration strategy, as this strategy aims at overcoming the limitations of both top down strategy and the bottom up strategy. So, this strategy, you can say, it is a mixture of both top down and bottom up strategies. Okay, and it is also known as mixed integration strategy. So, uh, uh, there are four strategies in bottom up, as bottom up integration. You can say top down strategy we have discussed, bottom up strategy we have discussed the limitations and advantages of top down and bottom up strategies also. Then we have discussed about big bang strategy and sandwich strategy. You always remember that the sandwich strategy is the combination of, or you can say mixture of, both two strategies, top down strategy and bottom up strategy. Let us discuss about the functional testing. What is functional testing? An alternative form of black box testing is to base the test data on the functionality of the module, which is called as functional testing. Okay, so what is functional testing? Functional testing is used to test data on the functionality of the module. Okay, and so you can say it is concerned with the functionality of the module. In functional testing, each function implemented in the module is identified, and from this, test data are devised to test each function separately. Okay, so what is the aim of function testing? Functional testing. Functional testing verifies that an application does what it is supposed to do and doesn't do what is it shouldn't do. Okay, so function testing usually includes testing of all the interfaces and should therefore involve the clients in the process. Okay, so because every aspect of the software system is being tested, and the specifications for this test should be very detailed, detailed describing who, where, when, and how will conduct the test and what exactly will be tested. Okay, and this portion of the testing that will involve the clients is usually conducted as an alpha test, where the developers closely monitor how the client use the system and they take notes on what need to be improved. Okay, so functional testing, you can say it is an important type of testing in which you are including, you are involving the client also. Okay, and client is interfering, or you can say he is aware of it, that what is expected from his side and what is to be delivered to him. Functional testing can be difficult for many reasons, like the functions within a module may consist of lower level functions, and each of which must be tested first. This is the first difficulty. Lower level functions may not be independent. This is again the second difficulty. And the third difficulty is functionality may not coincide with module boundaries that tend to blur the distinction between module testing and integration testing. So, this problem arises in the object oriented methodology when an object sends a message to a method of a different object. Okay, so these are some difficulties when you are doing functional testing. Functional testing falls into two categories: positive functional testing and negative functional testing. The When we talk about the positive functional testing, the testing entails exercising the applications functions with valid input and verifying that the output are correct. Okay, and uh, in the negative functional testing, the testing involves exercising application functionality using a combination of valid inputs, unexpected operating conditions, and other out of bound scenarios. Okay, so uh, the functional testing uh, first way of functional testing is the positive functional testing, and second way of functional testing is the negative functional testing. Okay, positive functional testing is related to the uh, valid input and verifying that the output are correct, whereas the negative functional testing uh, will check the functionality using a combination of invalid inputs, unexpected operating conditions, and other out of bound scenarios. Okay, let us discuss about the systems and acceptance testing. It is again very important testing type, and you can see that it is divided into several further divided into several parts, several types. So final stage of the testing process should be system testing and acceptance testing, and it is concerned with the execution of test cases to evaluate the whole system with respect to the user's requirements. Okay, so if the system is producing the output which is expected as per the expectation of client, then only the uh, result or the output is accepted. Okay, otherwise it have no use. Okay, so a system test checks for unexpected interactions between the units and modules, and also evaluates the system for compliance with functional requirements. Acceptance test is the process of executing the test cases agreed with the customers as being an adequate representation of user requirements, and these are also called as black box or functional tests. Okay, so acceptance testing, as name suggests, that acceptance testing system and acceptance testing is related to the acceptance of the output, client acceptance of the about the output. Okay, and these terms make reference to the test being unconcerned with the internal structure of the code, and they are concentrated on analyzing the performance of the code with respect to the test suite. Okay, so the process of retesting a unit during its development is called revision test. Okay, when you are retesting uh, a unit, means a module, during its development is called a revision test, and this is similar to regression test that occurs during maintenance when a system is being modified. So regression testing is the selective retesting of a system, or you can say a unit, to verify that modifications have not caused unintended side effects, and that the system or unit is still comply complying with the current specification. And this type of test involves examination of the whole computer system, all the software components, all the hardware components and any uh, interfaces. Okay, the whole computer based system is checked not only for validity but also for meeting objectives. Meeting objectives is the very important thing when you are developing a crucial project, or you are uh, uh, adopting you are starting the development of a big project. Then uh, identification of objective is one of the important thing. Okay, so the system and acceptance testing is uh, uh, having several types, like recovery testing is there, security testing, performance testing, reliability testing, robustness testing, stress testing, load testing, threat testing, and back to back testing. Robustness testing and stress testing and load testing are the part of reliability testing. Okay, let us discuss about recovery testing. Recovery testing uses test cases designed to examine how easily and completely the system can recover from a disaster. Okay, and it is desirable to have a system capable of recovering quickly and with minimum human intervention. And it should also have a log of activities happening before the crash, and a log of messages during the failure and upon restart. Okay, so recovery testing is concerned with the unpredictable condition or the disaster, means like power shutdown, like disk crash, interface failure, or insufficient memory, like problems. Okay, when software is working properly and suddenly a jerk occurs, then what will happen? Okay, how to recover, how much part is recovered. Okay, this is comes under the recovery testing. Then security testing is another important phenomenon nowadays, because uh, security is the major concern. How to secure data, how to secure software, how software is securing your data. Okay, so security testing involves testing the system in order to make sure that unauthorized access or unauthorized person or other systems cannot gain access to the system and information or resources within it. Okay, so programs that check for access to the system via password are tested along with any organizational security procedures established. Software's quality, reliability, and security are tightly coupled. These three things are tightly coupled. What is these things? Three things: quality, reliability, and security. Okay. Flaws in software can be exploited by intruders to open security holes. And with the development of the internet, software security problems are becoming even more severe. So there are several software applications and services have integrated security measures against malicious attacks, and the purpose of security testing of these systems includes the identification and removing software flaws that may potentially lead to security violations, and secondly, validation the activeness of security measures. Two things are there. First is identification and removing the software flaws that may potentially lead to security violation. And second is validating the effectiveness of the security measures. Okay. So in this sense, the security testing is very having very much significance nowadays. Let us discuss about the performance testing. Every software system, as you know, has its implicit performance requirements, and the software should not take uh, infinite time or infinite resources to execute. The software system should be free from performance bugs. Okay, performance bugs. What are performance bugs? What is performance bug? Performance bugs are used to refer to those design problems in software that causes the system performance to degrade. Okay, so what is related to the performance testing? Performance testing is related to the performance bug. If it is if there is a design related problems exist in the system in the software, then a performance related bug is there, you can say, and it will harm your system, it will harm your software. So performance has already been a great concern and a driving force of computer evolution, performance evolution of a software system. Okay, so uh, resources uses, throughput, simulates response time, and queue length, detailing the average or maximum number of tasks waiting to be served by selected resources are some issues that should be evaluated when you are going to perform the performance testing. Performance testing involves basically monitoring and recording the performance levels during regular and low and high stress loads, and it tests the amount of resources used under the just described conditions, and serves as basic for making a forecast of additional resources needed in the future. So performance related uh, uh, resources includes like bandwidth requirements are comes under the performance testing. CPU cycle is comes under the performance testing. Disk space and disk access operations are comes under the performance testing. Memory uses are the example are the issues comes under the you can say in the performance testing. Okay, let us come to the next thing, that is reliable testing. Reliability testing. Software reliability is a quality attribute, and reliability means refers to the probability of failure free operation of a system. Okay, reliability means a failure free operation of a system, and it is related to many aspects of software including the testing process, and it directly estimating software reliability by qualifying and quantifying its related factors like testing uh, procedure, like robustness, like stress, like load. Okay, so uh, testing is an effective stampling method to measure software reliability, and you can say that reliability testing based on some simple criteria like robustness testing is comes under the reliability testing. Stress testing comes under the reliability testing, and load testing is comes under the reliability testing. The robustness of software component is the degree to which it can function correctly in the presence of exceptional input or stressful environment condition. So, robust testing differs with the correctness testing in the sense that the functional correctness of the software is not of concern. It only watches for robustness problem such as machine crashes, process hangs, okay, or abnormal termination. These are the issues which is addressed by the which is to be addressed by the robustness testing. Let us discuss about the stress testing. Stress testing encompasses creating unusual load on the system in attempts to break it. Okay, so uh, stress testing is used to test the whole system rather than the software alone. Okay, in such tests the software or systems are exercised with or beyond the specified limits. So stress testing is subjecting a system to an unreasonable load while denying it the resources like RAM, disks, okay, interrupts need to process that load. If some component is uh, not able to uh, or able to uh, not able to get or bear the high load or uh, having some limited capacity, so you have to measure the stress uh, uh, bearable by the component or by the RAM or disk or interrupts. Okay, so so that the system does not failure. System uh, will not failure. Okay, get failure. Next is load testing. One of the most common but unfortunate misuse of terminology is treating load testing and stress testing. uh, Load testing is, you can say, subjecting a system to a statistically representative load. In load testing, load is uh, varied from a maximum zero to minimum zero to the maximum level of the system can sustain without running out of resources or having transactions suffer access delay. Okay, so load testing is related, is a, you can say, it is a synonym of stress testing, but it is somehow different from the stress testing. In the stress testing, you are calculating the stress uh, uh, to be beared by the uh, component, and in the load testing you are uh, calculating the load that is beared by the component. Okay, threat testing is a popular testing technique suitable for testing real-time systems, and in this type of testing the process of each external threats its way through the system process or objects with some processing carried out at each stage. Okay, and this type of testing involves identifying and executing each possible uh, processing thread. So this is about thread testing. The last testing is back-to-back testing. The back-to-back testing is used when several versions of a software system exist for testing, and all versions are tested with same set of tests, and then the results are compared for some system problems if exist. Okay, so it is a very important testing, a very easy method of testing. uh, in this method we are prepared, we have prepared a general purpose set of test cases, and using these test cases run the different system versions and store the results in different files, and then perform the automatic comparison of the results stored in different files and generate the difference report. So difference report indicates the system problem if exists among the different system versions. So this is a very important, very effective. Back-to-back testing is very effective type of testing. Uh, Let us discuss about the defect testing. Three special types of testing: defect testing, interface testing, and alpha and beta testing. Defect testing is aimed to at discovering the uh, defects before the system is delivered. Okay, So defect testing demonstrates the presence of program faults, not the absence. A successful defect test is that causes the system to perform incorrectly and thus exposed a defect. Okay, so what are the objectives of defect testing? There are two objectives of defect testing. The first objective is it is intended to show that the system meets its specification, and secondly, it is intended to exercise the system in such a way that latent defects are exposed. So exposure to the defects and identification of the defects are the purpose of defect testing. Okay. Interface testing is intended to discover defects in the interfaces of objects or modules. Interfaces defects may arise because of errors made in reading the specification misunderstanding, or errors or uh, invalid timing assumptions. Okay, so these are the major cause of interface interface errors. So interface testing is particularly useful for object oriented software development. Okay, the last one is alpha and beta testing. Let us discuss about the alpha and beta testing. Acceptance testing is also sometimes known as alpha testing. Okay, and the alpha testing process continues until the system developer and the client agrees that the delivered system is an acceptable implementation of the system requirements. When a system is to be marketed as a software product, a testing process called beta testing is often used. So, what is beta testing? Beta testing involves delivering a system to a number of potential customers who agree to use that system. Okay, they report problems to the system developers, and this exposes the product to real use and defects errors that may not have been anticipated by the system builders. So, after this feedback, the system is modified and either released for further beta testing or for general sale. So, alpha and beta testings are very important sort of testing. Let us come to the next point, that is object oriented testing methods. Because nowadays we are adopting the object oriented uh, programming styles, so it is very much important to generate object oriented to design object oriented test cases. Okay, so object oriented test cases needed to concentrate on the states of a class, because in the object oriented methodology, the class and objects are the important part of this methodology. To examine the different states, the cases have to follow the appropriate sequence of operations in the class. Okay, operations of a class can be tested during the conventional white box method and techniques, but there is some notation to apply these at the class level in class level instead. Okay, there are several methods like fault based testing is there, class level method is there, random testing, partition testing, and scenario based testing is there. The in the fault based testing, this type of testing allow for developing test cases based on the client specification or the code or the both, and it try to identify possible faults, okay, in the system. For each of these fault, a test case is developed to flush the errors out, and these tests also force each line of code to be executed. Okay, so you can say that this testing method does not find all types of errors. So incorrect specifications and interface errors can be missed. Okay, uh, and next one is class level method. As I earlier said, a class is most concentrated on in object oriented approach, and from here it should expand to other classes and set of classes. Just like tradition, models are tested by starting at the module first, and continuing to module cluster, and then the whole program. So class level method suggested what? To check the class first, and then to check the whole program. Okay. In the random testing, uh, it is based on developing a random test sequence that try the minimum number of operations typical to the behavior of the class. So in the random testing, you can generate random functions. Then partition testing is another an important part of object-oriented testing method, and this method categorize the input and output of the class in order to test them separately. This minimizes the number of test cases that have to be designed. Okay, like state, there are several categories of partitioning testing, like state-based partitioning that categorize class partition operations based on how they changes the state of the class. Then attributes based partitioning is there, that categorize class operations based on attributes they use. And the third one is category based partitioning that categorize the class partitions based on the generic functions of the operations performed. Okay. The last one is scenario based testing. This form of testing concentrates on what the user does, and it is basically involves capturing the user actions that then uh, simulating them and similar actions during the test. These tests tend to find interaction type of errors. Okay, so scenario based testing, you basically capturing the user actions and and then simulate them with similar actions during the test. So you can find some, uh, if you find some errors, you can then check it or resolve it. Let us discuss the automated software uh, testing tools. There are several testing tools uh, available, uh, uh, but we can categorize them all in these categories, like static analyzer. These programs analyze support proving of static allegations, weak statements about program architecture and format. Code auditors are there, assertion processors are there, test data generators, output comparators, symbolic execution systems, environmental simulators, and data flow analyzers. These are some automated software testing tools. As testing can be 40% of the all effort expended on the software development process tool, that can assist by reducing the time involved in, is useful. As a response to this, various researchers have produced set of testing tools, and these are the various categories of the testing tools. There are several companies also, like Rational, Mercury, Interactive, and CompuWare, etc. are some companies which are producing the which are providing the automated software testing tools. Okay, let us come to the debugging process. What is debugging, and debugging? What are the debugging? What is the debugging process, and what are the various debugging techniques? Let us discuss about the debugging. What is debugging? When a test case uncovers an error, debugging is the process that results in the removal of the error. So you can say that software testing is a process that can be systematically planned and specified. Test designs can be conducted, a strategy can be defined, and results can be evaluated against prescribed expectations. expectations. And debugging occurs as a consequence of successful testing. When a test case uncovers an error, Debugging is the process that results in the removal of the error. So you can see here the debugging process. This is the debugging process. Debugging is not testing, but it always occurs as a consequence of testing. Okay. The debugging process begins with the execution of the test case, and debugging is also treated as art, you can say. The debugging process is illustrated here. You can see here the debugging process, test cases generated for the testing and execution of cases. Debugging process starts with the execution of cases. Results is stored in the file, and debugging the result, suspected cases again, and additional test to be performed. Then uh, again test the generate the test case accordingly, and identify causes of the problem, make the corrections and make the regression test, and generate the test cases. So debugging is the uh, um, you can say the debugging process attempts to match symptoms with cause, thereby leading to error corrections. And there are mainly two outcomes of debugging. First is the cause will be found, corrected, and removed. Okay, the first outcome is that the cause will be found, corrected, and removed. And second is the cause will not be found. Okay, so there may be only two outcomes. Eh, as per the first outcome, the cause found, then corrected, and then removed. Okay, and the second expected outcome is the cause will not be found. So there are ample of techniques. There are so many techniques of debugging, like brute force debugging, uh, backtracking debugging is there, debugging by induction, debugging by deduction, cause elimination debugging, debugging by testing, and debugging by program slicing. Okay, let us discuss all one by one and in a very brief manner. Brute force debugging. When we talk about brute force debugging, it is applied when other methods fails. Brute force debugging is debugging with a storage dump. Brute force debugging is the most common debugging technique, but also the least efficient one. In this technique, the program is loaded with print statement to print the intermediate value, with the hope that some of the printed value will help to identify the statement with error. Okay, so people who use thinking rather than a set of help exhibit superior performance, and this approach becomes more systematic with the use of symbolic debuggers because value of the different variables can be easily examined. The second one is backtracking debugging. Backtracking is a fairly common debugging technique, and this involves backtracking the incorrect result through the logic of the program. And in this technique, the source code is traced back forward, backward until the error is discovered. Okay, so it is a backtracking debugging method. Then in the debugging by induction method, you can say it is a process that locates the data, organizes it, and uh, devised a hypothesis. And this hypothesis must then be proved. Okay, so debugging through induction and debugging by deduction. Debugging by deduction may also be used as a debugging technique, and it determines the possible causes and use data to eliminate causes. Refine the eliminating, define, refine the remaining cause into a hypothesis and prove it. Next one is cause elimination debugging. In this technique, a list of causes that could have contributed to the error symptoms is prepared, and tests are carried out to eliminate each cause. Software fault three fault free analysis is conducted for error symptoms, and software fault uh, tree analysis technique uh, is a very important technique, and it is used in the cause elimination debugging method. Debugging by testing is a again an important type. There are two types of test cases generated using it is a it is it can be done through the use of test cases. So test cases, there are two types of test cases. First is cases that expose a previously undetected errors, and second cases that provides useful information in debugging to locate an error. Okay. So for unexpected or undetected error cases tend to cover many conditions per test case, but test cases for locating a specific error covers a single condition for each test cases. So this is all about important debugging techniques. The last debugging technique is debugging by program slicing, and in this technique, this is very similar to backtracking. And in this technique, the overall search space is first divided in the program slices, so that the search is confined to the program slice only. And a program slice for a particular variable at a particular statement is the set of source lines preceding this statement that can influence the value of that variable. So you can debugging by program slicing, you can divide. It is much similar to backtracking. You can divide the program in program slice and then search it out for problems. So that's all from my side. In these are the very important concepts we have discussed, and now this is the time for self-assessment. Uh, the first through multiple choice questions. The first question is, what is testing uh, process's first goal? What is the first goal of testing process? Bug prevention, testing, execution, or analysis? Bug prevention is the testing first goal of testing process. The second question, software mistakes during coding are known as errors, failures, bugs, or defects. Software mistakes during coding are known as bugs. So right answer is C. Tests should be conducted for every possible data, every possible situation or cases, every possible variable. So what is the answer? D, all of the mentioned. Which of the following is not a part of the bug report? Test cases, output, software version, and LOC, line of code. Yes, line of code is not the part of bug report. Which of the following is not is the way of ensuring that the tests are actually testing code? Control structure testing, complex path testing, code coverage, or quality assurance of software? The answer is code coverage. Effective testing will reduce maintenance cost, design cost, coding cost, or documentation cost. Maintenance cost is the right answer. Debugging is dash creating the program code, finding and correcting errors in the program code, identifying the task to be computerized, or creating the algorithm. The answer is finding and correcting errors in the program code. Which of the following is not part of the test document? Test cases? Yes, it is the part of test document. Test strategy is the part of test document. Project initiation note and requirement traceability matrices. Requirement traceability matrix is the part of test document, but project initiation note is not the part of PIN is not the part of test document. So right answer is D. Which term is used to define testing? Evaluating deliverable to find errors, finding broken code, stages of all projects, or none of the above. Evaluating deliverable to find errors is uh, is the term is used to define testing. Yes, answer is A. Which of the following is not a valid phase of SDLC? Which is not the valid phase of SDLC? Testing phase is the valid phase of SDLC. Deployment phase is the valid phase of SDLC. Requirement phase is the valid phase of the SDLC, but testing closures are not the valid phase of SDLC. So these are the some questions, objective type questions we have discussed. These are some reference books you can consider when you have some query. Uh, I hope this lecture provided you a clear cut understanding about the topic that we have chosen for today. Uh, have a good day. Thank you.